In this video, we're going to learn about isotopes. Isotopes are defined as elements that are of the same kind that have different masses. So if we look at these two figures, we have an example of an atom on the left that has 2 protons, and the element on the right also has 2 protons. So because they both have 2 protons, they both are the same element. And if we look in the periodic table, just to be sure, they're both helium, since helium has an atomic number of 2. So these are both helium, and I can write both of these out as helium, Helium, but what I need to do is to distinguish one from the other is I need to recognize that one of them has 3 particles in the nucleus, and the other one has 4. So helium-3 and helium-4 are my 2 different names for these isotopes. Now, that 3 is the mass number, okay? That is the mass number, which is equal to the number of protons plus the number of neutrons. And if we look in the nucleus, we have 2 protons plus 1 neutron, gives us 3. Helium-4, it's 2 and 2. And I can actually fill in the mass numbers, since I know them to be 3 and 4. The atomic number is 2 for both of these because it's helium, and helium has 2 protons. Now, isotope symbol. If we don't want to write out helium-3, what we can do is we can write He, the symbol for helium, and write 3 over 2. That 3 is still the mass number. And the 2 is the atomic number, which may seem a little bit redundant since it's helium and you're specifying it as He here, so all helium has 2 protons. Why even mention the atomic number? I agree, it seems silly, but that is the convention that we use. For what it's worth, there is a little bit of convenience here in that if you see the isotope symbol and you're trying to figure out the number of neutrons, it's kind of set up as though it's a math problem, like 4 minus 2 is 2 neutrons. But I'm going to get that out of my answer to this problem. There are 2 neutrons in the helium-4, and there's only 1 in the helium-3. And you could count here, but even if you just have the isotope symbol, you can figure it out. As for everything else, well, the atomic number is the number of protons, so we have 2 and 2. And if we count the electrons, it's 2 and 2 for both of them. If it were the case of a helium positive ion, like let's say that we had 3 over 2 He with a positive charge, then I would need there to be 1 less electron than proton. So I would need to basically, I'd be looking at a diagram where one of the electrons was missing, and I would say that there's 1 electron. Everything else would be the same as the 3 over 2 He that we can see here. So that is that. Let's move on to a chart here and just go through an example or 2. So if we have the symbol 26Mg, and you can see here the 12 is missing, that sometimes you might find. More commonly, you do see the 12 here, and I put in the 12 because that is the atomic number of magnesium. But sometimes you might only see the mass number. It has to be in the top left, though. So atomic number for magnesium has to be 12. The mass number, we're looking at it right here, it's 26. The number of protons is 12. The number of electrons is going to be 12 because there is no charge. There's an implied 0 here. And the number of neutrons is simply going to be the 26 as our mass number minus the 12 protons is equal to the 14 neutrons. Just 26 minus 12 gives us our 14. Next, we have a case where the symbol is not given to us. We're given other information. So we know that there are 47 protons, and that's a good place to start. If I look here, 47 is silver. And I know the mass number is 109, so I can say silver 109. And I know the symbol is Ag since I was just looking at it. And I know the mass number is 109 and the atomic number is 47. So there's my atomic number. Now, why did I just write the symbol as this? I'm sorry, I just lost my mind, I think. So we have 109 over 47 Ag, and it would be silver 109 if we wanted to name it. Okay, so I do have to be very careful because here I see that there are 47 protons and only 46 electrons. So I'm one electron short of having a neutral charge. And if I take the protons minus the electrons, positive minus the negative charge, I have 47 minus 46 is positive 1. And if you do it in that order, protons minus electrons, you'll get the right sign of the charge. It'll be positive. I should also put in this 47 here. Now, the number of neutrons is just going to be that difference. 109 minus 47, 47, 50, 60, 70, 80, 90, 07, 08, 09. We have 52 neutrons. So that's going to be 52 neutrons, and there we go. So hope that helps. Let me know if you have any questions or comments in the comment section. Thank you.